So for the exam, you can count on at least one question in the open-ended part that has to do with a least square regression line. That's what we're looking at right here. Now in this case, we're looking at the relationship between protein and fat in fast food items. So it looks like that there is a relationship. As the protein goes up, the fat also goes up. Okay, letter A, describe the relationship between the grams of protein and grams of fat. So we might say it like this. There is a moderate, strong, positive linear relationship between the grams of protein and the grams of fat in the fast food items. Now remember, write your answers in complete sentences. Now, so like here, it's a moderate, strong, positive, linear relationship. Let's look at letter B. Is it reasonable to use a linear model in this case? Well, yes, you would say that the data closely resembles a straight line, but the other important part is this residual plot. Now, if you remember, if the residual plot is random, so something like this, the data looks to be somewhat linear and the residual plot shows no pattern. If the residual plot looks to be random, then a linear model is appropriate. So now they say write an equation, and we want to use the variables that they give us. So we are going to focus right here. In fact, it says the constant is 6.4. So I could use x and y and then define them, right? Say x equals the protein and y equals the fat. But a better way to do it would just be write it in there. So for every, well, let's see, they're going to ask us to describe this later, so let's go to letter D. So the slope of the line is right here. This is the slope. Now how would you describe that? You would say for every gram of protein that is increased is going to show an increase of 0.997 grams of fat. That's the relationship. So let's write that down. So now the last one says, interpret the value of S in context of the problem. S is right here, and that stands for the standard deviation. So the standard deviation is the average amount that we are off. So let's write that, something along those lines. So this is what standard deviation says. On average, the predicted amount of fat and the actual amount of fat can be off by about 9.3 grams. Now that seems like a lot, but that's because, look at this, R squared. The R squared value is 68.39, so that means that only 68% of our data can be accounted for by our least squared regression line. So in other words, our data is okay, but it's definitely not great. Anyway, there you go. That's number 1. So I guess in this one they have a pharmaceutical company that's testing influenza flu vaccines. One is injected, one is a mist, and then I think there's one that is the one that they use already. So they randomly assign 200 individuals, or 600 adults, ages 25 to 50, that becomes important later, to each one. Now, is this an experiment or observational study, and why? This is an experiment because we're doing something. The people in these groups are randomly assigned to a group and they are doing a treatment, some sort of experiment. We're not just watching them. That would be an observational study. So we have to establish what we're working with first. So we say, and I didn't write the whole thing out, but P sub I would be the true proportion of the population that respond to injection, and the mist would be the true proportion of the population that respond to the mist medicine, I guess. So of course we're going to say that the null hypothesis is that there's no difference the number of people that get the flu after the injection and the number of people that get the flu after the mist is equal. Versus, what would you think? We're just looking to see if they're different or not. So we should just put the alternative hypothesis, HA, is PI is not the same as the proportion of people get the flu after the mist. There you go. So again, I'm not going to write this whole thing out, but you want a control group for comparison. We may look at these two values and one is different than the other, but neither one of them may be better than the original. Okay, so we're going to take both these results and compare them to the original group in the end, just to make sure that they're better. Okay, so we really always have to look at, is it better than what we started with? Let's look at letter D. And then the last one, letter D, is, let's see, suppose you see that they are working for these individuals. Can this new vaccine for everyone? Everyone? Well, not everyone, because we only tested on people from 25 to 50. We don't know whether it's going to be different for younger people or elderly. So, we'd have to have a wider sample of the population. Okay, that's number 2. Okay, confidence interval. That's what they want on number 3. So let me write out the formula for a confidence interval. So there's the formula. Now we're going to have to do all of the number stuff. So the proportion is 558 out of 996, and we are at a 95% confidence interval. So there's our proportion to start out with, and our Z score is I put in the calculator for inverse norm, and it's a 95%, so we put 0.975 to get our number, which is 1.96, and then we do 0.56 and 1 minus 0.56 over the total, which was 996. 1 minus 0.56. There we go. Now that I wrote that all out, I'm going to go to Stat, over to Tests, and what am I going to look for? Well, this is a 1 proportion Z interval. Not a Z test, 1 proportion, let me find it. Letter A, 1 proportion Z interval. And I put in the numbers, and I'm going to tell you what it spits out. Let's see, I put in 558, 996, and we put 0.95, and we get this. 0.569 to 0.591. Hold on a second. I gotta take care of my dogs. Okay, so here is the interval, somewhere between these two numbers. So what are we saying? We are 95% confident that the true proportion of people that support this grassroots movement is somewhere between these two numbers. And the next part is interpret the confidence level. Okay, be careful. The confidence level in this situation. So, and the way that works is if we were to do this over and over and over again with the same sample size, 996 people, all of our intervals that we would come up with, 95% of them would capture the true proportion of the people that support this grassroots movement. So it's really important that you have this nailed down, confidence level versus confidence interval. So that will definitely be on the test.